In mathematics, especially order theory, the interval order for a collection of intervals on the real line is the partial order corresponding to their left-to-right precedence relation. 1. Interval I1 being considered less than another I2, if I1 is completely to the left of I2. More formally, a poset is an interval order if and only if there exists a bijection from to a set of real intervals, such that for any we have in exactly when. Such posets may be equivalently characterized as those with no induced subposet isomorphic to the pair of two-element chains, the free posets. The subclass of interval orders obtained by restricting the intervals to those of unit length, so they all have the form, is precisely the semi-orders. The complement of the comparability graph of an interval order is the interval graph. Interval orders should not be confused with the interval containment orders, which are the containment orders on intervals on the real line. Interval dimension. The interval dimension of a partial order can be defined as the minimal number of interval order extensions realizing this order, in a similar way to the definition of the order dimension, which uses linear extensions. The interval dimension of an order is always less than its order dimension, but interval orders with high dimensions are known to exist, while the problem of determining the order dimension of general partial orders is known to be NP-complete. The complexity of determining the order dimension of an interval order is unknown. Combinatorics. In addition to being isomorphic to free posets, unlabeled interval orders on are also in bijection with a subset of fixed-point free involutions on ordered sets with cardinality. These are the involutions with no left or right neighbor nestings where, for an involution on, a left nesting is in such that and a right nesting is in such that. Such involutions, according to semi-length, have ordinary generating function. Hence the number of unlabeled interval orders of size is given by the coefficient of in the expansion of